today we are going to take a closer look at our periodic functions of y equals sine x and y equals cos x. Again, theta and x are interchangeable as far as our variable for our angle. So we want to be able to graph y equals sine x and y equals cos x very quickly. So if you think about from when we graphed these the last day, our maximums were 1, minimums -1, with our x-intercepts every 180 degrees at 0. So we have key points that will help us graph these very quickly. And I'm going to go through this fairly quickly, but remember sine of 0 was 0. When we get to sine 90, it was 1. Sine 180 was 0. Sine 270 was -1. And sine 360 is 0. Well, those are our key points for one cycle. And that also continues the opposite way, -1, 0, 1, and 0. So these key points help us graph very quickly. And when we're setting up our grid, we want to keep in mind those key points. So we only have to go from 1 to -1. So we want to spread out a little bit. We don't want to have just a little small portion of our grid used. We can spread out our 1 and -1, just making sure that each block has the same value. And we want to do one cycle into the negative angles, one cycle into the positive. And because our key points are every 90 degrees, we want to make sure that those are plotted pretty easily. So what we're going to do is make 90 degrees every 3 blocks, which means that 180 is going to be every 6 blocks. So again, we don't necessarily have to label every single one of them, but we want to make sure that we have spots or places that we can plot very easily. Okay, and to start with, 0, 0, 90 and 1, 180 and 0, 270 and -1, and 360 and 0. And following the same pattern the opposite way, we have our key points. And remember, these are nice smooth curves. We didn't have straight lines approaching our points. They were nice smooth curves, and we have graphed our y equals sine x very easily. So we don't necessarily from now need to show our table of values. We can use our key points and graph this very quickly. And we can do the same thing with y equals cos x. So when you graphed this the other day, you'd notice that the difference between sine and cos at cos of 0 is a value of 1. So the smaller angles have a higher value. As you get to 90, it gets smaller to 0, and cos of 90 was 0. So cos 180 was -1, cos 270, etc. And again, if we look at graphing this, and let's take a look at our pattern as well. So again, we're going to use 1, same scaling that we did for our last graph of y equals sine x. So 2, 4, 6 is 180, 360, and instead of starting at 0, 0, we start at 0, 1. At 90 degrees, we're at 0. 180 is -1. Back to 0, and back up to 1. So we have our positive, or our cycle in the positive values for our angle. And our key points now, going backwards, we can see we're following the same pattern. And again, graphing another cycle of y equals cos x. So again, we can plot those key points very quickly, okay? And you want to get very used to those key points and plotting them very quickly to make our graphs. And we're going to use those key points to graph some transformations. Note that the transformations for any of our functions work the same way when they are placed into the function. So our plus 1 here at the end, like all of our functions, means up 2 units. Now, we're going to graph 2 cycles, one in the positive, one in the negative, and notice that stating the vertical translation is moving up or down. So our vertical translation is up 2 units. The other one we're going to talk about, and you're going to hear a fair bit, is phase shift. Phase shift is our left or right. When we talk about the phase of a periodic function, we're talking about the horizontal axis, our theta or our x-axis. So how has it shifted left or right? So we notice that there is no shift left or right for this function. Note that in this case, the period is still going to be 360 degrees, okay? Nothing has changed as far as a stretch or a compression to either the amplitude or the period. So we have to focus on how we need to label our grid. And sorry, in this case, our horizontal axis is theta. Okay, so we just look at our function to see that we're graphing theta. So our points, theta values or our angles are not changing. Our y values, though, we're adding 2 to. So we notice that for our y-axis, where our regular function, our max was 1, we now have to add 2 to that. So our maximum value for this one's going to be 3. Our minimum was -1, but we're shifting it up 1, which means our minimum value is going to be 1. So our whole graph is going to occur between 1 and 3 on the y-axis. Now, that means we're going to scale this a little bit differently than we did our base graph because we need to have up to 3 on y. So we're actually going to make every other one here. And just because we know we're not going to have any points down here doesn't mean we still don't want to label our grid. We still have a period of 360, so we are going to go every 4 is 90. And notice our key points so that we know exactly where those are going to go are fairly obvious. Okay, and now we can start to plot our points. What I would do in a lot of cases is graph my base graph of y equals sine theta. So we're going to do that 0, 0, 91, 180, 0, 270, -1, and 360. Now I'm going to put a dotted line in here because this isn't the graph that I want to end up with. Again, into our negatives following the same pattern. So now that I have my base graph, I know that it is just simply going to be shifted up 2 units. So I'm going to take each point and plot it up 2 units. And notice that we can still use our key points because we're still going over 4 blocks, down 2 or up 2 depending on the pattern. And we can see that that whole thing is just shifted up 2 units. Same thing with our graph here, following or using our same key points or moving each individual, whichever makes more sense to you. And there we have our graph of y equals sine theta plus 2. Next one, we have a phase shift. So remember, what's inside the brackets with x does the opposite as it appears, or as your y's do. So this is actually going to be a phase shift to the left 30 degrees, okay? Because that plus is in there, we put a negative 30 in there and we're shifting left 30 degrees. We have no vertical translation because we don't have anything at the end there. Our period, as we said before, is not affected by a phase shift or a vertical translation. So we still have an amplitude of 1, period of 360, but now we're going to be shifting everything to the left 30 degrees. So when we're labeling our grid, we want to keep that in mind. And our axis this time is x. So we want to be able to move 30 degrees easily. We're going to label our x-axis, each block worth 30. So we know exactly how to move it. So 30, 60, 90, 120, 150, 180, and 360. Same idea the other way. Every 6 blocks is going to be 180, or every 3 blocks is 90. Okay, and those help with our key points to know where we are scaling these. We don't have any shift up or down, so we are still going to have a maximum of 1. So we know we're only going to have to go up to 1 and down to -1. So we're going to stretch that out a little bit. Again, if we want to graph our base function, we can do that using our key points very easily. And we have, again, using a dotted line because this isn't our final graph that we want to use. And now we're going to shift everything left 30 degrees. So our original point becomes -30 and 0. Again, we can look at moving each of those points left 1 block, or we can still use our key points from the original point, whichever makes more sense to you, because we know our key points hasn't changed, our period is still the same, so we can still talk about using our key points as left 3, which is 90 degrees, and from 0 to 1 to 0 to -1, etc. And there's our graph of y equals sine x plus 30 degrees. Okay, and again, these are our base properties or our key properties for our periodic functions. And you'll notice that we are focusing on graphing our y equals sine x or y equals sine theta. Okay, we could do the same thing with cos, but we're going to focus on one of them at this point just to make sure we really know what we're doing here. Next one, we have both a phase shift and a vertical translation. Again, first thing to notice is that our period and our amplitude have stayed the same. We don't have any stretches or compressions or anything. At this point, we are going to be having a vertical translation down 5 units. And we have a phase shift right 60 degrees. So each of our key points, you'll notice this in here was just saying how are the values of each of our key points changed. So we could use our key points to alter them as well. We know that if we're moving to the right, we're adding 60 degrees to all of our theta values or our x values. And for our y values, we're going to be subtracting 5. So if we think about our key points, which were 0, 0, 90, and 1, 180 and 0, 270 and -1, and 360 and 0, we can look at changing these one by one. 0 plus 60 gives us 60, and negative 5 when we subtract 5 from the y. 150 and negative 4. 240 and negative 5. Okay, so we can alter those key points accordingly as well. We can do it graphically, whichever again makes more sense. I'm kind of going through a bunch of these just to make sure that we know one that works for us. So now we have to take a look at where our max was 1. We're taking away 5 from that. So our max is going to be negative 4. Our min, negative 1, taking 5 away from that means our max is going to be negative 4 and our minimum is going to be negative 6. So we have to think about that as we're scaling our grid. So we're going to go by ones on our y-axis, and again, even though we're not using the positive part of our y-axis, we still want to label that. So each block is 1, has a value of 1. For our theta axis, we want to make sure that we can shift 60 degrees. So if we make each block worth 30 again, we know we're just going to shift to the right 2 blocks. Okay, so remembering how or the value of each block. So if we do that, we're going to have 90, 180, 270, 360, negative 90, negative 180, negative 270, and negative 360. And as you're doing these, this scaling will get easier as you think about it and figure this out. So first of all, our base graph of y equals sine theta, if that's going to help us here. We know that we can follow our pattern, and again, using a dotted graph here of y equals sine theta. We now know we're going to shift to the right 2 and down 5. So each point is going to move right 2, which is 60 degrees, and down 5. We also know that we could use key points from here. Over 3, which is 90, and up 1, over 3 back to the middle, over 3 down to the bottom, over 3 up to the top. And again, opposite way as well. And we have our graph of y equals sine theta minus 60 minus 5. Okay? And again, totally up to you whether you're physically moving the points, moving your starting point, and thinking about where your key points fall. So, in general, and both of these, it doesn't matter whether it's sine or cosine, your key points change, but how it's altered doesn't change. So our period is going to be 360, our amplitude is going to be 1. There's nothing changing our period or our amplitude at this point. Our phase shift is the change in our theta values. So if we have minus d, we know that we're going right. If we have plus d, we've subbed in a negative value and we're going to go left. Our vertical translation, or our c value, plus c moves it up, minus c moves it down. So you can start with your base graph and move those appropriately. So you have some questions to practice, some graphs to create, remember that if it says sketch, we are actually going to use graph paper and graph it using our key points and transforming those accordingly. Okay, have a fantastic day, guys. Take care.